Alright, so today we're going to do some more solving of trig equations. So we have an example here, cotangent x times cosine squared x equals 2 cotangent x. So just like before, we need to solve the equations. There's more than one trig function now, so it's not going to be so much isolating the trig function, but we're going to start looking into factoring and some of those other methods for solving equations. So what we're going to do here is we're going to get everything on one side, and we're going to set it equal to 0. So cotangent x cosine squared x minus 2 cotangent x equals 0. Okay? And the reason we've done that is because there were a couple of terms that had cotangents in them, so now we can factor out the cotangent. And when we factor out the cotangent of x, we'll be left with a cosine squared x minus 2 equals 0. Okay? So just like with polynomials when we were solving those, if you've got an equation that's in factored form and it's set equal to 0, then that means that one of the factors must be 0. So either cotangent of x is equal to 0, or it's the cosine squared x minus 2 that's equal to 0. So now we're going to solve each of those independently. So x would be the inverse cotangent of 0, and this would give me cosine squared x equals 2, which means cosine of x is plus or minus square root of 2. Okay? So if I look at the first part with x being the inverse cotangent of 0, the angles that are going to have a cotangent of 0 would start out at pi over 2. Okay? And it would also be 3 pi over 2, which would be a negative pi over 2. So it might be better to say that we are going to negative pi over 2 plus n pi. Okay? Because there were no restrictions on this function, we have to be able to get all of those solutions. And the inverse cotangent is going to have a period of pi, because I would go from negative pi over 2 to pi over 2, then 3 pi over 2, but the inverse is only defined between negative pi over 2 and pi over 2. Okay? And on the flip side over here, cosine of x equals plus or minus square root of 2, so x is inverse cosine of plus or minus square root of 2. Okay? Well, the square root of 2 is more than 1. So there is no angle that has a cosine that's greater than 1. So this side, we would say there is no solution to that equation. So the only values we're going with are these values over here that we got from the cotangent part of the function. Okay? All right, next problem. 3 tangent cubed x equals tangent x. Now here we do have a restriction, so that might help us out a little bit. We won't have to have that pi n or that 2 pi n stuff going on there to get all of those infinite solutions. Okay, so again, I need to collect the terms on one side. So 3 tangent cubed x minus tangent x equals 0. And again, we're going to factor out. So we're going to factor out a tangent x, which would leave me with 3 tangent squared x minus 1 equals 0. So again, once it's factored, I take each factor and set each factor equal to 0. And then I solve. So this x would be the inverse tangent of 0. Over here, I'd go tangent squared x equals 1/3, which means that tangent of x would be plus or minus square root of 3 divided by 3. So x is the inverse tangent of plus or minus square root of 3 over 3. So I'll go back to the beginning. I say, okay, where is the inverse tangent going to be 0? Well, the inverse tangent is only defined from negative pi over 2 to pi over 2. Okay? So given that I'm only going between negative pi over 2 and pi over 2, then I would come up with x being 0 radians. Okay? And because I've got this boundary up here that I want all the values between 0 and 2 pi, what other angle between 0 and 2 pi would also have an inverse tangent of 0? And that's going to give me a value of pi. Okay? And over here, with the inverse tangent being plus or minus square root of 3 over 3, that's going to put me in the pi over 6 family. So the first quadrant would be pi over 6. I'd have 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay? So all of these values satisfy that initial equation of 3 tangent cubed x equals tangent x. Okay? Those are all the values between 0 and 2 pi that are going to work. Okay? Let's move on. 2 sine squared x minus sine x equals 0. Okay? As you look at this, you should see that it looks like some other things we've done. We've got a squared term there, and over here would be a sine to the first. That's a linear term. So this really kind of looks like a quadratic. Okay? So we're going to treat it as such, and we're going to factor it. So that would factor to 2 sine x plus 1 times sine x minus 1 equals 0. Okay? Factoring it just like a quadratic equation. If we wanted to, we could have used that u substitution and let u be sine x, and we would have had 2u squared minus u minus 1, okay? Which would factor to 2u plus 1 and u minus 1, and then we could replace our u's with the sine of x. Okay? So we got factored, so we're going to set each factor equal to 0 and solve each one. So this would give me sine of x equals negative 1/2. This would give me sine of x equals 1. So x is the inverse sine of negative 1/2. This x is the inverse sine of positive 1. Okay? And again, there were no restrictions given up there because I forgot to write it down initially. But let's go ahead and let's go here between 0 and 2 pi again for our solutions. Okay? So the inverse sine of negative 1/2 means I would have values of 7 pi over 6 and 11 pi divided by 6. And the inverse sine of 1 means that I would have a value of pi over 2. Okay? So 7 pi over 6, 11 pi over 6, and pi over 2 are all of the values between 0 and 2 pi that satisfy that initial equation. Okay? Moving on. And again, let's go ahead and put 0 to 2 pi for our restriction. So again, this looks like a quadratic. I've got a squared, I've got a linear, and I've got a constant. So I'm going to factor it again. So we'd have 2 sine of x plus 1 times sine of x plus 1 equals 0. Again, we want to set each factor equal to 0 and solve them individually. So sine of x is negative 1/2. Sine of x is negative 1. So x is the inverse sine of negative 1/2. And this x is the inverse sine of negative 1. So the values between 0 and 2 pi that have a sine of negative 1/2. Well, what am I going to end up with? I'm going to end up with 7 pi over 6 and 11 pi over 6. And over here, the inverse sine of negative 1, I'm going to get 3 pi over 2. Okay, so those are all of the angles between 0 and 2 pi that are going to have those values and satisfy that initial equation. All right, next one. Again, another quadratic. Okay, quadratic looking where we got a sine square, but this time it's a cosine in the middle instead of a sine. So it doesn't exactly fit our quadratic form initially. In order to treat it as a quadratic, we have to have all the same trig functions. Okay? So the first thing we can do is we can take and we can substitute, instead of sine squared, and make that 1 minus cosine squared. So that would give me 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. So when I move some things around here, negative 2 cosine squared x plus 3 cosine of x minus 1 equals 0. I want my leading coefficient to be a positive, so I'm going to multiply everything by negative 1. And now, once I do that, now I can factor. 2 cosine of x minus 1 and cosine of x minus 1 equals 0. So when I split them, this would give me cosine of x is 1/2 and cosine of x equals 1 if I set them equal to 0 and then just get the cosines by themselves. Okay. So x is the inverse cosine of 1/2 and x is the inverse cosine of 1. Okay. So, inverse cosine of 1/2. That's going to give me 5 pi over, or excuse me, that's going to give me pi over 3. Okay. And since there was no restrictions, we'll have to go plus 2 pi n, because I would get all those angles that are coterminal. Okay. Now another angle that has a cosine that is a positive 1/2 is also 5 pi over 3. And I would need all of its coterminal angles as well. Okay. So we have those two solutions. Over here, inverse cosine of 1. Well, what angle has a cosine of 1? That would be 0. And I need all of the coterminals, so I would have plus 2 pi n. Well, 0 plus 2 pi n is really just 2 pi n. When n is 0, I get the angle 0. When n is 1, I get 2 pi, and so on. Okay? So I end up with these 3 general solutions. All right, last problem.